Okay, this video is about numerical descriptive measures for a population. Population is the key word here. So up to this point, all of our examples have just been about samples. But ultimately, when we're doing research, what we're actually interested in is drawing conclusions about a population from that sample. So the idea here is that we go out, we collect a sample of size little n, from a population of size big N. And then we calculate sample statistics, so our sample mean, sample variance, sample standard deviation, to estimate the true population parameters. So what this means is we're interested in a population, so I'm going to represent it with a circle. So population. But I can't generally sample the entire population. It's just not possible. So what I do is I go in and I collect a sample. So I grab a subset of the population and I call that my sample. So let's just think about an example real quick. Let's say I wanted to know the average adult height of US population. Well, ideally, I would go out and I would sample everyone in the US, but unfortunately, that's not really possible. Why? Well, the US population is about 350 million people. So you have to go out and sample 350 million people, and no one's really has the time, the money, the resources to accomplish that. So obtaining 350 million observations, or we could think measurements because we're measuring height, is not feasible. Sorry, you can't really, that's just feasible. And so let's say, so thus we take a sample of size little n, and it could be anything. Let's say we sample 10,000 people. So we're interested in the average height for US population, which includes 350 million people. And so to get an estimate of the true population average, I take a sample. In this case, I'm taking a sample of size 10,000, and I'm going to calculate the sample average to estimate the population average. So here's a table, and let me actually get rid of this. So we have our measures. So we've calculated these things multiple times. So we've got the mean, the variance, and the standard deviation. So we've already calculated these before, so we should be familiar with the second column. So the sample average, or the sample mean, the sample variance, and the sample standard deviation. And what we're doing here is we're using these sample statistics to get estimates for our population parameters, which in this case are Greek letters. Makes us statisticians feel fancy. So we use the Greek letter mu to represent the population mean. We use the symbol sigma squared to represent the population variance. And then we use the symbol sigma to represent the population standard deviation. And you can see these formulas are very, very similar. So for the mean, they're the exact same formula. The only thing that's changing is that instead of using little n, we're now using big N. With the variance, same thing. We're changing little n to big N, but now we're going to replace x bar with mu, because mu is the population mean. And we're also only dividing by n, not n minus 1. And then with the standard deviation, we're just replacing s squared with sigma squared. So these population parameters on the right, these are our research questions. What is the population average? What is the population standard deviation? And to get estimates for our population parameters, we collect samples. So our sample is our actual data collected. So this is generally how research is done. We develop some sort of question, we go out and we collect a sample of data, and we calculate sample statistics, and those are our best estimates for the population parameters. So let's just think about some of the examples we've been working with so far. So our first example is just a sample of 6 homes in Latrobe, Pennsylvania. So our population would be all the homes in Latrobe, Pennsylvania. So here, little n is 6. I don't know how many houses there are in Latrobe, but I don't know. Let's say there's about 6,000. I want to know what the average number of bedrooms is in a Latrobe home. So I sampled 6, which is my guess for all homes in Latrobe, Pennsylvania. And then we sampled 5 St. Vincent students. And our little n was 5. And so I wanted to know the average high school GPA for St. Vincent students. So the true population number, the big N, I think there's about 1,700 students that go to St. Vincent. And then our exam question. So we took a sample of 9 of the scores. And let's just, for example, say there were 100 students in the class. So here, I'm just going to have big N be 100. And I just came up with that. And then down here, my sample of 10 commuting times. So N is equal to 10. That was 2 weeks of commuting. And I would be interested in what my true commute time is. So I've lived in my current apartment for about a year, and there's 52 weeks in a year. So 50, let's say big N is equal to 52. So 52 weeks times 5 days in a week, 5 work days in a week. So that would be 260. So if I wanted to know what my true commuting time is, I would have ideally sampled all 260 of my commutes that I've done since I've lived in this current apartment. So that's our population. And again, what we're doing is just we take a sample to calculate some sample statistics with the idea that we can extrapolate out to a population parameter.